Hey guys, so as you could tell by that incredibly silly video you just watched, we're going to be talking about something a little different today. Today we're going to be talking about inequalities. Now, at the very base of it, inequalities represent a comparison of two things that are not equal. Now that sentence in and of itself is kind of confusing. So let's look at what I did in the video so you can see the difference between an equation, which represents comparison of two things that are equal, so like 8 equals 8 and x equals 5, so that you can see the difference between something like that and an inequality. So let's look at what I did in the video. So, sorry. In the video, you'll notice that I did like 3 different sets of things. I did some kicks, some punches, I bit into an apple, and I did some blinks. And what I was doing there is I was showing you the difference between a situation that was set up by an equation and a situation that was set up by an inequality. So when I was talking about kicking 7 times, that situation could only be represented by an equation. Our kicks have to equal 7, okay? There is no other number of kicks that I could do that would get me exactly 7 times. 5 kicks does not equal 7 kicks, okay? So the only number of kicks that I can do based on this statement is 7. Now, looking at the other situation where we were talking about punches, it says punch a maximum of 5 times. Now I want you to think about that for a second. How many punches could I have done? Is there only one number of punches I could have done? No. I could have done 1 punch because that's less than 5. I could have done 4.5 punches, that's less than 5. I could have done no punches. The only stipulation I was given was that I had to punch a maximum of 5 times. Okay, that is a situation that we would represent with an inequality because there's more than one exact possible solution that would keep the statement true. Punching 4 times still gives a true statement of punching a maximum of 5 times, right? When I say kick 7 times, there's only one number of kicks that I can use. So this represents an equation. This represents an inequality. Okay, let's look at the apple. When I was biting into that beautiful green apple, exactly 2 times, that's the thing. This situation is represented by an equation because I was giving exact directions. There's only one number that would satisfy this situation. For me to bite the green apple 2 times, I have to bite it 2 times. I can't bite it 3 times. I can't bite it 1 time. I have to bite it 2 times. Okay, if I want to bite the beautiful green apple at least 3 times, this situation is an inequality. Okay, I don't have to bite the green apple 3 times. Okay, it says at least 3 times. There is more than one number of bites that I could choose to do. I could choose to bite the apple 5 times. I could choose to bite the apple 8 times. I could choose to bite the apple 90 times, as long as it's at least 3 times. So this situation could be represented with an equation. This situation would be represented with an inequality. Because once again, this situation represents something where the bites are equal to 2. This situation represents bites that aren't necessarily equal to 3. So once again, it's an inequality. It's not equal to 3. Okay? We're comparing the bites to 3. All right, let's look at the last one where I was blinking 9 times and blinking less than 13 times. You've guessed it. This represents an equation because the blinks have to be 9. That's the only number that would work here. For me to blink 9 times, I have to blink 9 times. I mean, it sounds silly, but it's as simple as that. This could be represented by an equation because there's only one value that makes this true. This is an inequality because if we are comparing the blinks to 13, the blinks don't have to be 13. Okay? They need to be less than 13. So we are comparing blinks to the number 13 by saying that the blinks have to be less than 13. So once again, there's more than one number of blinks that I could choose to do here. I could blink 8 times, I could blink 4 times, I could blink 2 times. I blinked half a time, which is a wink. But once again, the point here is that an inequality represents a comparison where there is more than one possible value that makes it true. This is a comparison between blink and number of blinks, where the only number of blinks I can choose is 9. This is a comparison between blinks and 13, where it could be many numbers, as long as it's less than 13. Now, just like how we have a special symbol to represent equations, we also have special symbols to represent inequalities, which you have seen before. Okay, so if we are dealing with inequalities, we use these symbols. Okay, we have the greater than or equal to, less than or equal to, or not equal. These are all used in inequalities because all of these allow us to compare two things without saying they're equal. Saying that 5 is less than 6 is not saying that it's equal to 6, it's saying that it's less than 6. Okay, 4 is also less than 6. Okay, so once again, it's a comparison of two things that are not equal. Once again, these notes will be posted, so you're welcome to look over them at any time. Now, in math, we try to be general. We try to represent situations as generally as possible so that we can apply rules that we know about. Okay, so like on the warm-up yesterday, y'all had your triangle, and this was like 32, and that was 53. Okay, you knew that all three of these angles had to add up to 180. So we used, or when I was teaching some kids, I used an X to represent something we don't know, and now I just have an algebra problem. Once we have represented this situation with this equation, we can use rules that we know about to figure out what our number is. Okay? So we're going to look at how we use algebraic equations algebra to represent inequalities, okay, versus equations. If I want to represent this situation, okay, once again, we talked about how it has to be an equation because my kicks have to equal 7. I can simplify this even more by using just a variable to represent my number of kicks. My kicks have to equal 7. K has to equal 7. If I wanted to represent this situation with an inequality, okay, it says punch a maximum of 5 times. So my punches, that's not how you spell punch. My punches could be equal to 5, but it's a maximum of 5. So 5 is the highest number. Therefore, punches have to be less than or equal to 5. So again, we're going to simplify this by using a variable to represent punches. Okay? So P needs to be less than or equal to 5. So again, if you compare these two, there's only one number for K I could put here that would make this true. The only number I could put here is 7. 7 equals 7. Okay? Here, there's more than one number. I could put a 3 here, and 3 is less than or equal to 5. I could put a 2 here. 2 is less than or equal to 5. Okay? So remember, that's the difference. Equations, you can only replace that variable with one thing. Inequalities, there is more than one number you could replace that variable with. Let's look at one more. So if I'm looking at the number of blinks, once again, this is an equation. So how we're going to represent that is we're going to use an equal sign, okay? And I'm going to say my blinks had to be equal to 9, or b equals 9. Okay, for blinks less than 13, we're just going to write out that sentence. So blinks have to be less than 13, or b is less than 13. So this is a mathematical expression that represents the same situation as this sentence with words. Now, this box here is important. It's just saying, it's giving you values for k, and it's saying, does this make my statement true? If I replace k with 11, does that create a true statement or not? Okay. On this page, it talks about graphing. I think I'm going to make a separate video about graphing because this has been kind of long.